Alright, let's get some shear stress going on. Okay, so this thing, think of it like a chin-up bar. And right here it's going to support something really heavy. So this rod goes through something. And we can't see that rod anymore because it's in the middle. In the middle of our heavy thing. Here's our heavy thing. Oops. And it's, well, we know how heavy it is. So you can see what's going on here. This thing's pulling down with a lot of weight, and if this rod were spaghetti, it would shear that spaghetti. It would shear it here and here. So there's shear stress in these two different places. Fortunately, this is not a piece of spaghetti. This is a bolt that's more than 1/2 an inch thick. It has a diameter of 9/16 of an inch. So our job is to find the shear stress in the bolt. Again, stress is like pressure. So we got pressure being force per area. That's nothing new. What is new is our little symbol, tau, for shear stress. And also new, let's not use P, let's use V. That's the variable for shear force. Alright, that's better. And we're given V here, 4,100 pounds. And the surface area we have to figure out from the diameter. So we know that the area of a circle is pi r squared, r being the radius. And the radius we know is half of the diameter. And here we have to square the half as well as the d. So when you square half, you get a quarter. So that's where this divided by 4 comes from here. So we just came up with a little equation for the surface area of a circle if we know the diameter rather than the radius. So we can reuse this again in the future if we want. And we have a area, and that's the cross-sectional area. I have a bad feeling like I said surface area a minute ago. So is it really this simple? Divide one number by another? No. Here's what makes this question interesting. Here's why there's a video on it. The shear force V is really distributed between these two planes, right here and right here. We could imagine this bolt breaking by shearing there or shearing there, or, well, both. But the important point here is that force is distributed over these two places. So really, we should put in V over 2 because we have a double shear going on here. So let's put in our shear force and divide it by 2, and then divide by the surface area. And this was pounds per square inch.